So good morning, everybody. Thanks, Max, for kicking off the day. It looks like it's off to a great start. So I'm also here to talk about something a bit of a controversial pre-confirmation. I want to see a show of hands, like how many people in this room actually heard of this term, pre-confirmation. Okay, a few. Who think they actually understand how it works thoroughly? Okay, so this is going to be a good talk because it's a pretty high level and it's a good intro. So first off, who we are. So we are Luban. We're a research and product company, aim to build novel financial primitives for block space on Ethereum L1, maybe L2 later. So we're here to accelerate what we call the multidimensional block space market through the proposer commitment, because we see that the block space currently being buy and sold is not very efficient because there's not a very transparent and efficient marketplace for that, and we're here to change that. So our first product iteration for this particular mission is called TaiYi. It's a L1 pre-confirmation protocol. So what is pre-confirmation? So by definition, pre-confirmation is a deterministic commitment that allows the user to secure future block inclusion or execution with a sub-second soft finality and deterministic base fee. So in fact, pre-confirmation is actually nothing new. It's just a term that people recently just invented. But pre-confirmation predates even Ethereum. So I think in the early days of Bitcoin, some people started discussing about the pre-confirmation. And currently today, L2s, they run this centralized sequencer. They give user a confirmation once the user click the swap button or submit transaction button. That's in fact pre-confirmation because nothing is being executed. It's simply stored in the centralized server's local database. So soft confirmation, pre-confirmation is essentially the same thing. So why this? So this is really nothing new. But what we looked at this is that we see a lot of similarities between confirmation, pre-confirmation, and the futures and forwards contracts in traditional finance. So futures contracts, just in case you are not familiar with this, is basically a legally binding agreement where you can buy or sell a specific asset at a predetermined price for a future date. So it's already on the surface, it looks somewhat similar to the concept of the pre-confirmation. So side by side, we can see this kind of similarities between the two. So in the futures, we have a strike price. Pre-confirmation is basically the pre-conf tips, or basically the sequencing fee that you pay to centralize a sequencer today on L2. So futures, the seller of the futures, we need to put up a collateral. And here, at least according to our design, we use the restake the ETH for this particular purpose. Settlement is basically when the seller delivers the physical good to the buyer. So here we have the transaction inclusion and the execution that's being either settled on L1 or L2, depending on the context. The counterparty here is basically the buyer will be the user who buys the block space, and the seller will be the validator, so on and so forth. But there's a primary difference between the two, is the fungibility of the block space. So the block space is actually not that fungible. So on a particular block, we know that the top of the block will always be more valuable than the rest of the block. So that's what I mean by that. So that's, in my opinion, what makes pre-confirmation not necessarily a futures contract. So since we're talking about a futures pre-confirmation, so let's narrow the scope a little bit from a very high-level abstraction of a pre-confirmation to a more down-to-earth, like low-level design of how actually pre-confirmation is manifested through one of the designs. So there's a new design paradigm called a base rollup. So in simple terms, base rollup is basically rollups whose sequencing is driven by the L1 proposer. So because of the L1 proposer, the L1 block time is 12 seconds, so it lacks this kind of optimal UX experience that a user would normally enjoy using a regular L2, L2 that runs a centralized server. So we have this new design called a base pre-confirmation or base sequencing, where the validator in this particular block time can issue this fast confirmation to the end user. So there's no sacrifice to the user experience there. So since we're already talking about the L2, it's beneficial to actually understand how the L2 block space economy works. So in simple terms, L2s make money by resell L1's block space. So the L2's operators, they buy L1 block space, resell that to the L2 users, then they charge a margin on top of that. That's basically a sequencing fee. That's basically how they make money. The reason why they are able to charge money, a margin on top of the money they pay for the L1 block space is because they provide optimal user experience to the end user. So the revenue model roughly is basically the sequencing fee, mostly driven by the UX premium. So there are many L2s out there. So they are all in one more or less competition with one another. So basically, this is how they make money, the cost and revenue breakdown. Like the cost at this point is basically just the data availability and execution on L1. DA these days is essentially free, even though you use blobs on Ethereum L1, like you pay probably like less than $5 for a couple epochs. So it's essentially free. So the bottleneck is basically driven down to the execution. Again, execution is actually also very cheap. So the reason why the L2s are able to make money today is because some L2s can actually really rent seek on their users. So actually added a slide there, but I think it probably wasn't included this one here. But basically, there was a diagram shared by the SMG, by Max last week, where the base was able to charge a sequencing fee on top of their base fee, where they can basically make more money from their user. So what are the implications of this kind of economic model for base rollups? So base rollups as this kind of a new design paradigm trying to take on the incumbent, they have to offer fees that are comparable or lower to the non-base rollup counterparties. So how low? So the lower bound should be just basically benchmarked against the theoretical price for the execution futures given a particular market condition. So to get close to this theoretical price at a point in time for the executions futures in the reality, we need to introduce a competition among multiple parties instead of have just one single rotational leader. Otherwise, we have a similar scenario that we have with other rollups, for example, Base, Optimism, or Arbitrum there. Like they are basically able to overcharge their user to basically rent seek from their user. So what we want is not like an RFQ-like system where we have a centralized server, but we introduce more competitions in the process, which really drives down the price for the end user. So that's kind of the design principle for us. So that's the talk. Thank you.